All right, we are going to look at how to factor something that looks like this. Now, if you notice, all of the polynomials on this page in this lesson are binomials. They're binomials. And we are going to reverse FOIL, but these are all special types of binomials, and they are called difference of squares. Now, in math, the word difference means subtraction, and squares means, a four-sided shape. But if you remember, when we first started talking about exponents, we talked about a list of perfect squares. So squares refers to that list of numbers. So that list is 1, 4, 9, 16, 25, 36, 49, 81, 100, and so on. I could keep going. But 1 is 1 squared, 4 is 2 squared, 9 is 3 squared, 16 is 4 squared, 25 is 5 squared, and so on. So this is called a difference of squares because we have subtraction in the middle, and both of these are perfect squares. We have 1x squared minus 25. Okay? Now, let's think about this. What do I really have in the middle here? I really have a 0x in the middle. Now, let's say I want to factor this, reverse FOIL it, just like we have. Well, to get x squared, I have to do x times x. To get 25, I can do 1 and 25, or I can do 5 and 5. Now, I have to have x and x. I have to have plus and minus. And what combination is going to work out so that I have 0x in the middle? Well, that would be 5 and 5. Now, if you notice, these factors are exactly the same. It's just one is a plus and one is a minus. So this is how difference of squares works. It's like a little shortcut. If I have a difference of squares, a squared minus b squared, this will factor into a plus b times a minus b. So it's like a shortcut. So let's try this one. These are both perfect squares. 1x squared minus 16. What do I have to multiply together to get x? X and x. What do I have to multiply together to get 16? 4 and 4. Make one a plus and one a minus. Let's try b. Difference of squares. 4 is a perfect square. 9 is a perfect square. What would I have to multiply by itself to get 4x squared? It would have to be 2x and 2x. To get 9, it'd be 3 and 3. We make one a plus and one a minus. Let's try c. 25x squared. What would I have to multiply by itself to get 25x squared? 5x and 5x. 1 is 1 times 1. Make one a plus and one a minus. All right. I would like you to pause the video and try D, E, and F on your own using the shortcut for difference of squares. So pause the video, give these 3 a try, and check back when you're done to see how you did. All right. Check over how you did. Remember, the factors are exactly the same. The only difference is that one of them has a plus and one of them has a minus, and that's true for every single one of these that we've done so far. All right, example 2. First, factor out greatest common factor. So what we have to look for is there anything that these terms have in common? Is there anything that I can divide both terms by? And in this case, the answer is yes. I can divide both terms by 4. And if I take 4 out, I'm left with 4x squared minus 1. Now, look at what I have left in the parentheses. That right there is a difference of squares, so I can keep going. The 4 comes along for the ride, and then I keep factoring it. What would I multiply together to get 4x squared? It would be 2x and 2x. To get 1, 1 times 1, make one of them a plus and one of them a minus. All right, let's try part B. 25x cubed minus 4x. Look for greatest common factor. Well, there's nothing I can divide both 25 and 4 by, but they do both have an x. I can take an x out of both terms. If I take an x out, now I only have 25x squared minus 4. But again, look at what I have left. This is a difference of squares, so I can continue to factor this. And notice that x stays along. What would I multiply by itself to get 25x squared? 5x times 5x gives me 25x squared. To get 4, it'd be 2 and 2. Make one of them a plus and one of them a minus. How about C? Anything I can divide both 8 and 50 by? I can take 2 out. Do they both have an x? No, in this case they don't both have an x. The only thing I can take out is 2. If I take 2 out, I have 4x squared minus 25. And again, these are perfect squares. So 2x times 2x gives me 4x squared. 5 times 5 gives me 25. Make one of them a plus and one of them a minus. All right, just like before, I would like you to pause the video and try these last 3 on your own, then check back to see how you did. All right, so for each of these, you should have taken out the greatest common factor, and then what you're left with is a difference of squares that you can continue to factor down into those similar factors, just like that. All right, that is it for lesson 4, and we'll see you soon to go over everything from Unit 11, and we will have a quiz over Unit 11 next time you're in class.